All right, welcome to another exciting problem on Math Counts. This is the 2013 chapter target problem number 6. Alex, it's all about you, Alex. Why you swear on my video already? My goodness. Way to go, Alex. Yes, this is a live recording with Alex in hand. So, Alex added the page numbers of a book together and got a total of 888. Unfortunately, he didn't notice that one of the sheets of the book was missing with an odd page number on the front and an even page number on the back. Now that's going to be important, knowing that the smaller of the two numbers that is missing in the count has to be odd, and the larger of the two numbers must be even. Okay. What is the page number of the final page in the book? Now, before we get started, the one sort of thing that we have to know, and I'll do a little lesson on this one, and then we'll do the problem, is how do you find the sum of a sequence? Now, you're going to probably tell me that what are the important parts of a sequence that we need to know?
Range.
Okay, hold on a second. So we need to know the range.
Counting number and the sum.
And the sum of the first plus the last number. So those are the things I need to know. And the equation that we're going to use is the range divided by the counting number plus 1
times the sum divided by 2. Yeah, over 2.
divided by 2 and over 2, that works. It means the same thing. Now, here's the sort of interesting thing in this case. If the counting number is 1, we just have r divided by 1, which is r. So we get r plus 1 times the sum over 2.
4 times 2.
Now, when we are dealing with a sequence that is counting by ones, again, this only works when you're counting by ones, the range is going to be 1 less than the largest number. Because you start at 1 and you count every number. So the largest number plus the smallest number will be the largest number plus 1. Yes. So that means the range will be the largest number minus 1. But wait a second, we still have the plus 1. And for the sum is always going to be the largest number plus the smallest number, and the smallest number is, in this case, is always going to be 1. So that means this is going to be n plus 1. So the sum in this case will be n plus 1. The range in this case is going to be n minus 1 plus 1, which is just equal to n. And we're going to still divide it by 2. So I'm going to be using the equation n times n plus 1 divided by 2, because this is a stripped down equation for finding the sum of a sequence that only works when you're starting with 1 and you're counting by ones. If I didn't start at 1, or if I wasn't counting by ones, you'd have to go back to this equation. Does that make sense?
Yeah.
Okay. So I'm going to clear this. I'm going to use my master equation over here. Yeah, and one equation to in the darkness bind them. All right. So we know that if I add all of the numbers together minus those pages, I will get close to 888, right? So just for the moment, I'm going to pretend that the whole book is complete, that we haven't lost any pages. So that would mean that n times n plus 1 divided by 2 would have to equal 888. Okay, well, let's do some train tracks here. What will I do to both sides?
Multiply by 2.
Multiply by 2. When I multiply by 2, I get n times n plus 1 is equal to 1776. It's a great year to have a revolution.
Why?
Almost.
Are you serious?
Before
That
we
was
do math,
the-
why don't we work on our social studies or history?
In 1776, the United States signed a document called the Declaration of Independence.
Just in case you didn't know. Just in case you didn't know.
But I appreciate your laser focus on math.
Welcome to history.
All right.
Math.
So we know that n times n plus 1 is equal to this number. Okay. Now, using the distributive property, I can say n times 1. So I get n squared plus n is equal to 1776. But you know what? This is not an exact equation because I am missing a page, which has a number on the front and a number on the back. So we know this equation isn't going to be perfect, but it will give us a good place to start. My n squared number is going to be a lot bigger than my n, because n squared is n times n. That's going to be a lot bigger than this. So to give me a ballpark idea of where I should be looking, I'm going to take the square root of 1776. So pull up my calculator. I'm going to do 1776. I'm going to, thank you. I'm going to squirt it. So I get n is going to be somewhere close to 42. Now, as luck would have it, spoiler alert, if you don't want to know the answer, cover your ears. The answer is 42.
Yes.
But I will show you why we know that is true. So n is close to 42 because n squared plus n is close to 1,776. All right, but we don't know exactly where it is. So I'm going to plug the 42 into my master equation and see what is the sum of all of the digits from 1 to 42. So let's go ahead and do it. You're just here in the right time. So what is my n value? 42. I want red. And we have a little British accent thing going on the background. All right. So what is n here? It's still 42 plus 1, and we're going to divide it by 2. 42 plus 1 is?
43.
So I have 42 times 43 divided by 2. Let's reduce. 42 divided by 2 is? 21. So I get 21 times 43. I'm allowed to use my calculator in this round, so 21 times 43. And I get 903. So hold on a second. So if I add all of the digits from 1 to 42 together, I will get a sum of 93. Well, 93 is larger than 888, which makes sense because I ripped a page out. Okay, so let's subtract these. Let's see what the difference is, because the difference will give me a clue as to what page I ripped out. So when I subtract these two, I get 15. Are there two numbers that are sequential that added together make 15? Will. 7 and 8. Oh. And remember, the odd number has to be smaller, the even number has to be larger. So I ripped out 7 and 8, which means that my largest number on my page numbers is 42.